This is the third discussion on definite integrals. I'm just redoing the sums and I'm getting rid of the change of the limits. What I do is I just do not see the limits at all. I will just try the I'll change the question like this, that we have x e to the power x square dx is, as discussed in the previous video, x square is taken as t, so 2x dx is dt. So this is 2, this is 1 by 2, so this becomes 1 by 2, 2x dx gone as dt. So this is e to the power t, and that is equal to 1 by 2 e to the power t dt is e to the power t plus c. That is 1 by 2 e to the power, in place of t, write as x square plus c. So this is the way we are doing if there is no limit, or this is the way that the normal indefinite integral is done. Now finally, now I'll look at the limits. Is equal to, therefore this is equal to 1 by 2 e to the power x square 0 to 1. As I told that in definite integral the plus c won't remain. I was doing indefinite, so plus c was here, and as I have made into a definite by putting the limits, this problem has changed into the definite integral part, so plus c won't remain. Now 1 by 2 is a constant coming off. So this is 1 by 2 e to the power 1 square minus e to the power 0 square. This is e to the power 1 minus 1. So this is 1 by 2 into e minus 1. So what I'm doing basically is, you can make out that I'm doing indefinitely, but when I was going with the indefinite integral, I was finally writing where t is x square, and I was leaving the answer there only. But in this, you should write the value of t finally, get the answer in terms of x basically, and once it is done, then put the limits. That's it. And this can be done to any form of question. Do not see the limits. Get this one's answer by indefinite method and finally place x values. The same process is followed for this. So without looking at this, x e to the power x dx, if you have followed the last discussions properly, you can come to know that this is in the form of islet or the by parts. So this x integration of e to the power x minus e to the power x plus c. Finally is x e to the power x minus e to the power x. I'll do one thing, I'll take an e to the power x common here so that it will be easily done. So e to the power x into x minus 1, the limits are put. So now what I'll do is, in place of x I will write 1. So this is e to the power 1 into 1 minus 1 minus, now I'll put e to the power in place of x zeros. So this is e to the power 0 into 0 minus 1. Take care of this bracket because there is a binomial coming. There is no necessity of putting a bracket, even though many books and many students attempt to put. Try to understand in maths where to put brackets, where not to put brackets. So this is e to the e into 0, which is 0, minus e to the power 0 is 1. This is minus 1. I do not require any bracket here, but if you require, you can give a bracket. I don't mind. So this is 0, minus into minus is plus. This is 1. While you're solving this, at the last step, at some problems, the plus minus symbols will be that close that you may miss. So while you're doing these all steps, you should never be fast. Should be damn slow. Then only you'll get the correct answer. Because if you are getting by chance the negative answer or some a wrong answer, this is mathematics, and any error is 0. If it is like this, the similar trend, 1 plus x square is t, so 2x dx is dt. So there is a 2, there is a 1 by 2 without bothering the limits. So limits were 0 to 1, so this is 1 by 2 dt by t. So this is 1 by 2 log of t plus c, which is 1 by 2 log of t is 1 plus x square plus c. Here I come with the limits 0 to 1, x by 1 plus x square. The question is, the answer is 1 by 2 log of 1 plus x square. Here I go with the limits, 0 to 1. 1 by 2 is a constant coming out, so this is 1 by 2 log of 1 plus 1 square minus log of 1 plus 0 square. So 1 plus 1 square is 2. This is 1. Log of 1 is 0. So this is coming to be 1 by 2 log of 2. I believe I could convince you how to do definite integral quite comfortably.